morning, boys. Class 11. In our last class, you have seen the pH, problems of pH, ionization constant of water, Kw. The value of Kw equals to 10 to the power minus 40 at 25 degree centigrade temperature. And from that you have seen that pH plus pOH equals to 40 for aqueous solution. That is the first part. We have also discussed about strong electrolytes and weak electrolytes. Strong electrolytes dissociate almost completely in water. Weak electrolytes dissociate very poorly, feebly in water. So depending upon their degree of dissociation, we have two types of electrolytes, strong electrolytes and weak electrolytes. You have also seen some of the examples of weak electrolytes. Some acids are there, some bases are there. You have seen those examples. Now today we shall discuss about the concept of acid and base. Acid and base, according to Arrhenius concept. Arrhenius concept. Arrhenius concept. An acid is a substance which furnishes hydronium ion in aqueous medium. See, for example, hydrochloric acid HCl plus H2O dissociates to form H3O plus and Cl minus. Acid is a substance which furnishes hydronium ion in aqueous medium, according to Arrhenius. And base is a substance, supposing this is a base, NaOH plus water, H2O to Na plus aqueous plus OH minus aqueous. Base is a substance which furnishes hydroxyl ion in aqueous medium. Here you can write in place of water plus Aq in aqueous medium. So this is acid, it furnishes hydronium ion. This is base, it furnishes hydroxyl ion. And the acid, strength of acid depends upon the concentration of hydronium ion. H3O plus concentration. This concentration sign, this denotes the strength of acid. And OH minus ion concentration of this, it determines the strength of base. Greater the hydroxyl ion concentration, greater will be the strength of the base. Greater the hydronium ion concentration, greater will be the strength of acid, according to Arrhenius concept. And acid and base, they react with each other to form water. That is, you know that acid and base react with each other to form water. That means these two things will react, this plus this will react with each other to form water, 2H2O. So according to Arrhenius, acid and base react with each other to form water. This is neutralization reaction. We say neutralization reaction, as you know. Neutralization reaction means the acid and base react with each other to form a neutral solution, a solution of salt and water. So this is known to you. Second concept is Brown state, Lowry and Brown state concept. Brown state concept. According to this concept, Lowry and Brown state concept, an acid is H plus donor and base is H plus acceptor. So see, the concept is very simple. What is acid? An acid is proton donor and base is proton acceptor. This is according to Brown state concept. So see here, if you write HCl plus H2O from here to here, you see that HCl is a substance which donates proton. It donates proton. HCl donates proton to form Cl minus. And if you go from here to here, you see that water is accepting a proton plus H plus. So water is accepting a proton and HCl is donating a proton. So according to Bronsted theory, HCl is acid and water is base. Because you know that acid is proton donor, so this is donating the proton, that's why it is acid. And base is proton acceptor, this one is accepting the proton, so it is base. So water is base and HCl is acid. Therefore you can write here this acid 1, this one is base 1. If you look at the backward direction, see Cl minus to HCl. So Cl minus to HCl, if you look at the backward direction, you can say that Cl minus is accepting a proton to form HCl. So Cl minus is accepting a proton, this one plus H plus. If you look at the backward direction, Cl minus is accepting a proton to form HCl. So Cl minus is base. So this is base 2. And H3O plus, if you look at the backward direction, it is donating a proton. It is donating a proton to form a water. Therefore, H3O plus is acid 2. Therefore, you have a pair acid 1, base 1, acid 2, base 2. This concept you see, it's a relative thing. HCl in presence of water, HCl is acid and water is base. And from that side, if you see Cl minus and H3O plus, Cl minus is a base and H3O plus is acid. You can say that Cl minus is the conjugate base of the acid HCl. Cl minus is the conjugate base of HCl. See, similarly, if you write here H3O plus, this is the conjugate acid of what? H3O plus, conjugate acid of water. So these two things you understand. You have conjugate acid base pair. What are the conjugate acid base pair? I am writing here HCl slash Cl minus. It is conjugate acid base pair. And another one is H2O slash H3O plus. This is another conjugate acid base pair. See here. Therefore, you can say that this is the conjugate acid of the base water. This is the conjugate acid of the base water. This is the conjugate base of acid HCl. So it's a conjugate acid base pair. You see that conjugate acid base pair differ by a proton. Conjugate acid base pair always differ by a proton. See what is the difference? The proton is the difference. What is the difference? A proton is the difference. Therefore, you can say here that A1B2 is conjugate acid base pair A1B2 and another is B1A2 is another conjugate acid base pair. B1A2 is another conjugate acid base pair. So this is Bronsted concept. First of all, you see that Bronsted concept says that acid is proton donor, base is proton acceptor. Now you consider any reaction in the reversible way. That means whether it will go in the forward direction or backward direction, this doesn't matter. In some cases it will go in the forward direction, in some cases it will go in the backward direction also. This matters. So A1B2 is a conjugate acid base pair, B1A2 is another conjugate acid base pair. Conjugate acid base pair always differ by a proton. Next point is, according to Bronsted concept, a strong acid has weak conjugate base. So remember, this is a very important fact. Strong acid, it has weak conjugate base, and vice versa. As you know, HCl is strong acid, therefore Cl minus is a weak conjugate base. As you know, water is a very weak base. अगर water को हम base मान ले, water is accepting the proton, so it is a base. Water is weak base. Water is weak base, therefore H3O plus is a strong acid. A weak base has strong conjugate acid. A strong acid has weak conjugate base. This thing can be understood clearly. So in this case, you will understand that relative strength of acid and base. You know that ammonia is a weak base, therefore ammonium ion will be a strong acid. See, according to Bronsted theory, ammonia, as you know, ammonia is a weak base, therefore NH4 class, this will be a strong acid. Similarly, water H2O is a weak base, its H3O class is a strong acid. Look at the pairs. HNO3 is a strong acid, therefore NO3 minus is a weak base. NO3 minus is a weak base. It's a strong acid, it's a weak base. As you see, carbonic acid H2CO3 is a weak acid, therefore CO3 2 minus is a strong base. Look at this. There are some species according to Bronsted theory. For example, NH3, for example, water H2O, for example, HSO4 minus. There are some species, see, which can act as acid as well as base. Ammonia conjugate NH4 class. See, if ammonia is a base, its conjugate acid is NH4 class. If ammonia is acid, its conjugate base is NH2 minus. Look at this. Look at this species. Ammonia का बात करें, ammonia is a base and its conjugate acid is ammonium ion. Ammonia को acid मानेंगे, ammonia is acid, then its conjugate base is NH2 minus, amide ion. This is amide ion, this is ammonium ion. Water, if you consider it water as base, then its conjugate acid will be H3O class. If you consider water as acid, then its conjugate base will be OH minus. Look at this table. HSO4 minus to H2SO4. See, HSO4 minus, if you consider HSO4 minus, its weak base, then its conjugate acid H2SO4 is strong acid. If you consider HSO4 minus is acid, then its conjugate base will be SO42 minus. So see, what is the difference H plus? 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 So look at the middle one. The middle one, ammonia, water, bisulfate ion, these can act as acid as well as base. किसी रिएक्शन में एसिड का काम करता है, किसी रिएक्शन में बेस का काम करता है. सिमिलरली वाटर भी किसी रिएक्शन में एसिड का काम करता है, किसी रिएक्शन में बेस का काम करता है. जो भी करे, अगर वाटर का नेचर, अमोनिया का नेचर, बाइसल्फेट आयन का नेचर हमें मालूम है, तो इसका कंजुगेट एसिड, कंजुगेट बेस कैसा होगा उसको भी हम लोग को पता चल जाएगा. जैसे अमोनिया को एसिड मानोगे तो वीक एसिड है, तो अमोनिया वीक एसिड, therefore NH2 minus is a strong base. Amide, सोडामाइड, NaNH2 strong base. अमोनिया को बेस मानोगे तो it's a weak base, therefore ammonium ion is strong acid. Look at the nature. You have seen water here. Now if you write ammonia plus water and complete the reaction, see here, this will be NH4 plus OH minus. So ammonia to NH4 plus H plus, and water to OH minus H plus. So what is the nature? Ammonia acting as, ammonia is proton acceptor, ammonia is base, water is proton donor, water is acid. So in this reaction, water is acting here as acid, and in base depending upon with which it has been taken. When you take water in presence of HCl, water will act as base. When you take water in presence of ammonia, it will act as acid. So there are many substances which can act as acid as well as base according to Bronsted theory. And again it says that a weak acid has strong conjugate base, a strong acid has weak conjugate base. So this point is very important for you. And now Lewis theory of acid and base, that's a very general theory. According to Lewis theory, an acid is electron pair acceptor and base is electron pair donor. Anything that can donate a pair of electrons to another thing, to another substance, that will be called as a base. And anything that will accept a pair of electrons, that will be called as an acid. This is the Lewis concept, most generalized concept. By this concept, you can classify many substances which are weakly acidic and many substances which are weakly basic. Even if they have a slight basic tendency, Lewis concept can recognize it. For example, BF3 electron pair acceptor, so BF3 is acid. Boron trifluoride, electron pair acceptor, so BF3 is acid according to Lewis theory. And ammonia is electron pair donor, so ammonia is a base. So it does not depend upon the relation, the relative things. Whenever a reaction is taking place by the transferring of electron pair between the two species or between the two substances, you can recognize one as acid, another as base, according to Lewis theory. And this theory is very important for organic chemistry. Even if there is a slight acidic nature, Lewis theory can recognize it. Slight basic nature, Lewis theory can recognize it. Lewis theory is most generalized theory. It can even recognize the slightest amount of acidic nature or basic nature found in a substance, present in a substance. Clear? This much is today's class. You will read these three concepts: Arrhenius concept, Bronsted concept of acid and base, and Lewis concept of acid and base. Okay, next class we shall discuss about the weak acid, their dissociation, and how to find the pH and pOH of weak acid and weak base. Okay boys, thank you. So next class we shall see here again.